Let's look at some examples that will illustrate the behavior of a JK flip-flop. Here we have three examples that are going to be pretty straightforward, I hope. The first example, you can see here that we have a JK flip-flop. I'll observe first of all that because there's a bubble on the clock, this is going to be an active falling edge. You can see that J is attached to 5 volts, so that's going to have a value of 1. K is attached to 5 volts, so that's going to have a value of 1. And because both of those contain a 1, I know that this is going to be in its toggle configuration. And in the toggle configuration, we just simply are going to have the new value is going to be the opposite of whatever the old value used to be. So since it used to contain a 1, I know that Q is going to go to a 0. Over here, I see still active falling edge. I see that J contains a 1 and that K contains a 0. This is going to be the set configuration, and therefore Q, no matter what it used to be, is going to go to 1. In the third example, I see that they both contain a 0, so J contains a 0, K contains a 0, and whenever J and K both contain a 0, that's going to be the hold configuration, and therefore Q is going to stay at whatever value it used to be. Q used to have a 1, so Q is still going to stay with a 1. So those examples weren't too hard, but the important thing to realize is you first of all have to figure out the values of J and K. Then you have to figure out which function you're going to perform. Is it hold, set, reset, or toggle? And then figure out what's going to be the new value of Q. Down here we can see that again we're going to have an active falling edge on the clock for both of these two flip-flop examples. We see that J still contains a 1 right here, but K is attached to Q bar. Now this is entirely feasible. It's actually done quite a bit. Q contains a 0 before the active clock edge. So if Q contains a 0, then Q bar must contain a 1. And that Q bar is going to be fed back into K, so that K will also contain a 1. J equals 1, K equals 1. This is toggle configuration. And since this is toggle and it used to contain a 0, Q is now going to transition to the opposite, which will be a 1. Over here, I can see that K contains a 0 and Q contains a 0. That 0 is going to be routed right back into J. J and K both contain a 0, so this is going to be in the hold configuration. It's going to hold whatever it used to have, so Q is going to continue to contain a 0. The third set of examples, Q contains a 1. You can see now that both J and K are being routed from the outputs. So if Q contains a 1, Q bar must contain a 0. Well, that must mean that J gets a copy of that 1 and K gets a copy of that 0. So J equals 1, K equals 0. This is in the set configuration, and therefore Q is going to go to 1 no matter what it used to contain. Over here in the second example, Q starts out as 1. Q bar starts out as 0. The 1 is actually going to be routed down to the K, and the 0 is actually going to be routed over to the J, and so now it's going to be J equals 0, K equals 1. This is the reset configuration, and if it's in the reset configuration, Q must go to 0.